Hello and welcome to our week 8. I hope you're doing well and enjoying your week so far. Now the agenda for today is to mostly go over this week's assignment, which is Lab 3. We are in the final stretch of our boot camp, so we have Lab 3 this week, then we have Challenge 3 next week, and we are done with the boot camp. Not the class, but just the boot camp. And this week's lab will focus on a very important concept in programming, which is error handling. So without further ado, let's dive right into the Lab 3 assignment. Now I already downloaded the Jupyter Notebook file from our Module 8, and I open up here in Google Colab. To start, please make sure that you read everything in the text area, and I'm going to jump straight into the coding part, and I'll read the reading up to you. Alright, so here is a sample code cell, and basically says we're going to print, so basically we're going to output, let's divide 10 by 0 or a letter. So we know in typical mathematics, if you divide anything by a 0, that's an error, and also if you can't divide a letter by a number. Okay, so we're supposed to get an error. Then we have an input function which prompts the user to enter a number 0 or a letter, and then we're going to take this inputted value, we're going to convert it into an integer using the int function, just so we could use it in mathematical operations like a division function. We're going to assign this to a variable called number, and then here we're going to do the actual calculation. We're going to take 10 and then we're going to divide it by whatever the number value that was stored in this variable, and then this is going to be assigned a value of result. Then we're going to have a print statement that says 10 divided by whatever the number is whatever the result is. Okay, now I'm going to run this multiple times. I'm going to show you first that it will work with regular numbers. So if I run this, here it's prompting me to enter a number, 0 or a letter. So let's just say 2. Okay, I know that's not what it's asking for, but I just want to show you that it works fine. I hit 2 and I get an answer. Okay, I didn't get an error. Now let's run it and let's follow instructions. I'm going to type 0 and then hit enter, and now I get a traceback error. Okay, and the actual error is it's a 0 division error, division by 0. Again, you cannot divide a number by 0. Alright, again, this is fine to get as you are coding your application, but when you launch this application into production where users are using it, it's not best programming practices to leave an error unhandled like that. So we have to always gracefully handle every error. But this is what an error would look like. Now if I run it again and instead of 0 I type in some sort of a letter, so let's say P, hit enter. Okay, I also get another error. It's a traceback error, but the type is called the value error. Okay, because that value P is not accepted to be divided by a number. Alright, so this is what would happen if you don't gracefully handle your errors in your code, and so that's why we need to come up with a better way to handle errors. So in Python and in all programming languages there are error handling mechanisms that we just need to apply. So in Python we have the try and except block, and this is the bare minimum because there is try, except, else, and finally blocks as well. But for this code example we're just going to introduce a try and except. So try is a reserved word in Python programming language as well as except. So in the try part, you need to put in any code that you think might generate an error. So as a developer, you as the programmer, you need to anticipate what your users might or might not do that can generate an error. So there's a lot of forward thinking a bit that you have to come up with as a programmer. So in this code up here, I know that this input function and the dividing by a number that is incorrect number will generate an error. So I'm going to take the possibly error-prone code and wrap it up in a try block. So I took the same code from above. All right, again, this is the input function, and then we convert the value to an int because the default input value is of the data type string, and then again divide by 10 and then print out the result. Okay, so this code can generate some sort of an error. Now the two errors that we can think of is the 0 division error and the value error. Again, these are what we saw up here. This time was called value error, but the previous run it gave me a 0 division error. Okay, so I'm going to have a try block, and then indent it, and the try followed by a colon, and then indent anything that I want to include in this try block. And if there's an error that gets captured, then it's going to go to one of these except blocks. Now, these except blocks are very specific. So this except block is only going to be triggered if we have a zero division error. Okay, nothing else. And if we have a except of the value of the type value error, then we're going to get this indented code run. Okay, so this example here is very specific to the type of error we're going to get. Technically, you don't have to specify the exact error since you might not capture every single possible error. So we can basically just use the word except and not specify the exact error type. And I'll show you that in just a moment. I'll modify this code in just a moment. All right, so let's run this code and see how it runs. Okay, again, this is very similar to what we've seen before. So enter the number 0. I'm going to do 0 and hit enter. There we go. So this time around, the code did not blow up in my face with a traceback error, but we caught the error because it's a zero division error, and we gracefully handled it by printing out this statement, which we see here. Okay, so this is much cleaner and much better, and again, part of best programming practices because we are now handling our error. All right, now let's try to generate on purpose a value error. So I'm going to divide my value by a letter. Let's do K this time, and then hit enter. And it says, that doesn't look like a number. Let's stick to numbers for now. Okay, so there are multiple errors that can be caught. They're called exceptions. So if the exception is of the zero division error, I can handle it this way. And if the error is of the value error, then I can handle it this way. Okay, now a lot of people or a lot of programs don't need to specify the exact error because they just want to have one generic error for all errors, which sometimes doesn't make sense, but sometimes in specific applications we can do with one generic error. So what I'm going to do here is, again, this is not required of you, but I just want to show it to you. I'm going to erase all this. All right, so what I did here is I removed the two different exception types, and I just kept the word except, which now is telling me that any error that gets generated from this code, I'm going to capture it in this except block, and I'm going to handle it by printing out this statement. Okay, so now I have a generic exception catch-all. All right, it's not going to tell me what the error is because I have it here, just one sentence for everything. So now if I run this code now, and I'm going to divide by 0, which should give me a zero division error, hit enter, we have some sort of an error because the exception got caught. Okay, I didn't specify the type of the exception, I just said any exception. Run this code. Okay, now if I do a string value, hit enter, I also get the same exact behavior because I'm catching any error or any exception. And when I do catch an exception, this is the treatment I'm going to handle when the error has happened. So now you see that we can have a very generic way of catching errors, or we can specify our errors by doing what we had before, which is this guy here. We are specifying the anticipated error types, and then we're catching them and treating them differently accordingly. All right, let's move on to the next. Again, remember, you always need to read everything on this page. I'm not going to read it for you, but please read it because it has a lot of helpful information. Now, here it says that Python has many built-in functions, and these are some of the built-in functions. So you can get zero division by error, which we saw. You can get a type error. We didn't see that, but type error basically is when you're expecting a specific data type, like you're expecting an integer, but somehow a string was passed, or you're expecting a dictionary, but a Boolean was passed, and so on. Value error is what we saw also before. Index error is when you have an index, say an index of 5 items, but you are trying to call index number 7, which doesn't exist. So it's going to give you an out of range index error. Key error is, for example, when you're trying to call a key in a dictionary. Remember, dictionary is key value pairs. You're trying to call a key name in a dictionary but doesn't exist. This is going to give you a key error. And then we have a keyboard interrupt. I actually do this a lot when I'm coding or when I'm working in a terminal window where my application is running and I want to abruptly terminate it. I do a Command C since I'm on a MacBook, but if you're on a Windows computer, you can do Control C. This is going to generate a keyboard interrupt error. And then we also have a file not found error, which you probably have seen when working with files already. Sometimes you call a file to either read it or write it or save it or whatever, and that file doesn't exist. well, it's going to generate a file not found error. All right. So here are examples of all these errors, and we're going to run them one by one. So zero division error, which we saw before. So we're going to attempt to divide 10 by 0, and we're going to print out the result. But of course, this is going to give us a hiccup. It's going to throw a traceback error because we cannot divide by 0. So we saw that already, but let's run it again. All right, so I get a 0 division error, and the text for it is division by 0. That's not allowed. All right, now this is a type error where we're trying to add the string 2 to an integer 2. Now we know by now that we cannot add, or we cannot concatenate mathematical values that include non-integer values or non-numerical values. So we can't add a string 2 to a integer 2. So, and that because again that's a type error. Strings and integers, you can't really mix them together like that. So if I run this, I'm going to get another traceback error, and the error is a type error. It says we can only concatenate string, not integer, to string. Okay, so you can technically add a string to a string, and if we do that, we're basically going to get not 4, but we're going to get 22, because we're going to concatenate a 2, the string 2, to a string 2, and when we run that, we get 22 because we concatenated, not mathematically added, we concatenated 2 with 2. All right, let me take this back and then run it again. We're going to get the type error. All right, next one is value error. So value error is when you're expecting a certain value, but you give it another type value. So the integer function expects some sort of a value that will be converted into an integer. So usually you can take a string and convert it into an integer, but the string needs to be some sort of a number and not text. I mean, you can convert the string 2 into an integer, which will make it still 2, but instead of being a string type, it's going to be an integer type. Okay, but if I run this as hello, hello doesn't have a comparable integer value. So if I run this code, this is going to give me a traceback error of what type? Of the value error type, because hello is not a string value that can be viewed or interpreted as an integer as well once converted into that data type. The next one is index error. So I mentioned that an index error is going to happen if you have a certain index, but then you try to call an index item that's outside the range of this index. So here we have a list of index items 1, 2, 3. And then I'm going to call this list by its name and then give it an index location of 5. So 5 is not part of this index, so it should give me an index error. So let's run this. I get a traceback error, and then the type is index error because list index is out of range. Next example is key error. Again, I explained that the key error is when you try to call a key in your dictionary, but the key doesn't exist. So here I have a dictionary called mydict. And then in the key value pairs, I have key A with value 1, key B with value 2. But then in my code, I'm trying to call from my same dictionary, I'm trying to call a key, okay, or a key that has a keyword of C, and there is no C keyword in my dictionary. So if I run this, I'm going to get a traceback error, and the type of the traceback is a key error. C does not exist. And now we come to our very first challenge. Here's a program that's supposed to print out a user's favorite fruit, but it has a bug that can cause an error. Okay, so here's the code. Here's my list of fruits. I have apple, banana, cherry, and then I have an input which prompts the user for this. Enter the index of your favorite fruit, 0, 1, or 2, and then whatever gets entered, which is a string type, it's going to be converted into an integer, so I could use it as a number in my index code for my fruits list. Okay, so again, whatever number I enter, it's going to get stored in a variable called index. Then I'm going to call my list, which is called fruits, and I'm going to pass it a number, either 0, 1, or 2, and that's going to get assigned a new variable called favorite fruit, because once we look up fruits 0, that should be basically apple. Fruits 1 should be banana. Fruits 2 should be cherry. Okay, and then that's going to get stored to this variable, and then I'm going to print out your favorite fruit is favorite fruit. Okay, now if I do 0, 1, or 2, then everything should be fine. Okay, because 0, 1, and 2 are within my range of my index. So let's test it out. Okay, I'm gonna put 1, so I should get banana. Yep, your favorite is banana. No errors there. Now if I go outside my index range and I type 4, for example, then I'm going to get a traceback error. Here it is. And the type of error is index error because the list index is out of range. Okay. Now, all the challenges, I basically completed the code for you just because I don't want to type a lot and waste your time. So our first challenge says basically to modify the above code, which is this code here. So modify the above code to handle exceptions. All right, it's basically raised when a user enters a number that's out of range or the user enters a non-number. And then print a helpful message if either or these occurs. All right, so for you guys, you can have an empty cell here, but what I did is I basically copied all this code and then pasted it down here. All right, and then as you can see here, here I have the fruits defined, and then I have the index, and then the new variable, and then a print function. So I define my fruits by itself, and then these 3 lines of code, which I think can generate an error. Again, defining a list is not going to generate an error, but then these 3 can generate an error because they're going to be using indexes, and sometimes indexes can be out of range. So I basically lumped these 3 lines in a try block. Now remember, try is followed by a colon, and then the code in it needs to be indented. Remember, always indent your code when need be, of course, in Python. All right, so I'm going to attempt to run this code in a try block. If everything runs fine, then everything's going to run fine. But I could also get an index error, or I could also get a value error. An index error is going to happen if I type something outside the index range, which I can, or I might get a value error because instead of typing a number, I type some sort of a string. All right. So this is my interpretation of this challenge. And it says, you know, print helpful message if either of these occur. So if someone enters an index error or enters something that generates an index error, then I'm going to type, oops, that index is out of range. Please enter a number between 0 and 2. So this is nice and helpful. But if they type something else that's not a number, then I'm going to say, that doesn't look like a number. Please enter a valid index. All right, I can say index number to be exact. Okay, so let's run this and let's test it by trying to break our code. So to test a index error, I'm going to type 5. All right, great. So instead of getting a traceback error and a lot of ugly looking messages, I gracefully handled the error by generating a nice message to the user that explains what the problem is. All right, so now we tested the index error, we can capture it and we can gracefully handle it. Now let's test the value error. I'm going to type anything, hit enter, and now this generated the value error because it's expecting some sort of a number, and I type or I output, that doesn't look like a number, please enter a valid index number. All right. So again, this is how we should, as programmers, anticipate the type of errors, lump up all the error generating or error prone code into a try block, and then anticipate the type of errors that we think might get, and then each error should be handled differently. All right, so far we've been talking about the try and except, but I told you there is more to try and except, and there's also else and finally. So this little text here explains to you exactly what try does, what except does, what else does, and what finally does. Okay, so try basically is the block of code where we attempt to run the code that might cause an error. Except block is basically where if an error happens, we go to the except block and we run or we handle the code as we see fit. Now the else block is basically says if no errors happen in the try block, the code in this block runs, and this is optional. Okay, so we don't always have to have the else block just like we saw up here. We just have try and except. So try and except, if you have a try, you have to have an except. So the minimum is to have a try and except. The else statement is basically optional. Okay, and then we have the finally block. Now this block of code runs no matter what. If the try block runs, you're also going to run the finally block. But if the try block fails and you go to except, then the finally block will also run. So finally is always going to run. All right. So here again, try is going to attempt to run. If there is an error, except is going to run. Else is going to run only if the try block does not generate an error. And then the finally block is going to run regardless if it runs fine or generates an error. All right, and here's a simple example of the code that uses the try, finally, and else. So again, similar to our code that we used before. We have a try block. I'm going to lump the code that might generate an error. We have a few except types, zero division by errors, except value error, which we've seen before. And then we're going to have an else block. And again, the else block runs if this try block did not generate an error. So we're going to run this try block. Everything's fine. Then we're going to also run the else block. We're not going to run the except block because the try block did not generate an error. So run the try. If it's successful, we're going to run else. And then since we have a finally, finally is going to run regardless if error or no error. So on a happy path, this is going to run, and this is going to run, and this is going to run. On a failed path, this is going to attempt to run. It's going to generate an error. Depending on which error it is, either this is going to run or this is going to run. But this is not going to run. The else block is not going to run because there was an error. But then finally it's going to run because this runs regardless if you have an error or no error. Okay, so let's run this and test it. Okay, first I'm going to run it with successful or happy path. So enter a number, let's say 2. So 2 should not generate an error. Okay, so I entered the number 2. 10 divided by 2 is 5, okay, which is this line here. And then great, no errors occurs, which is this line here. That's the else block. And then this code runs no matter what. This is this line here, which is the finally. So in a happy path, the try runs, the else runs, and the finally runs. Okay, now let's try a zero division error. So I'm going to run this again. I'm going to enter 0, hit enter. All right, so this ran, I got prompted. I didn't make it down to here because this generated an error, and the type of error was zero division error. So then I jump to this exception block. I run this print statement, which I see down here. And then I do not run the else block because else only runs when the try has successfully completed. But I do run the finally because that runs regardless if there is an error or no error, which prints this code runs no matter what, and I see the output here. Okay, all right, let's move on to the next. Again, any text, please read it on your own. All right, now it's time for another challenge. Here's a program that's supposed to calculate the square root of a number entered by the user, but it has a bug that can cause an error. All right, so here's the code. Okay, we didn't add yet error handling, but the code is we're going to import the math module, and then we are going to prompt the user to enter a number to find the square root of. And since we're working with numbers, we want to convert it to a float. Now, a float is different from an integer, where it means we can have decimal points. And then that gets assigned to a variable called number. And then this number, I'm going to call the square root method of the math module, which I imported. So that's going to basically take the square root of whatever number I entered. That's going to assign it to a new variable called result. And then I'm going to output the square root of number is result. Okay, so if I run this, all right, and I type, for example, 9, square root of 9 is 3. So I hit this, and I get 3. It's fine, okay? Now what happens if I don't type a number? I type, something. Then I get a traceback error, which is expected because of a value error. It's expecting, a number, and I gave it the value of a string. All right. So this program has two issues. Okay, it doesn't handle the case where the number enters a negative number. Okay, I didn't even test that. All right, and it doesn't handle where the user enters a non-numeric number like a letter P, which I actually did test by typing the string something. So our challenge is to modify the above code to handle exceptions raised when the user enters a negative number or a non-numeric value. So if I go up here again and run this code and I give it a -9, I get a traceback error, and it's a value error, math domain error. Okay. All right. So here's my solution to the code. Again, I basically took the lines that I think can generate an error. and I lumped it into a try block. Okay, again, I copied pretty much the code from here. Again, the import is not error prone, so I left it alone, but these 3 lines are error prone, so I lumped them into a try block. With a try, you have to have at least one except, so I'm going to look for an except of the type value error. And now I'm going to also add an else statement, and the else statement basically is just going to print out a statement that says square root calculation successful, which we know that the else only runs when the try has been completed successfully. And then for the finally block, I'm just going to print a statement that says this code always runs. All right, you can do something else in the finally block, not just print statements. You can do any kind of code you want. You can close files, you can send an email, you can do, update a database, you can do anything you want. All right. And so this is my interpretation of that challenge, which is updated with a try, except, else, finally blocks. All right, so let's run this and test it. Now I'm going to try to break it right away, so I'm going to do -9, hit enter. So that's much better now. Instead of getting the traceback error we saw up here, I am now still getting an error, but it's not blowing up in my face. I'm capturing the error by printing out invalid input, please enter a non-negative number. Okay, so we caught the error as a value error, and then we printed out this statement. Now the else block did not run because we have an error, so I don't see the output here, but the finally block ran because finally is going to run regardless, and this code always runs, which is the output of this print statement. Okay, now if everything runs fine, okay, if I just do 9, not negative, then the square root of 9 is 3, which is this print statement here. And then I'm not going to go into the except block because no exception has been raised. Then I go to the else, and finally, because else is going to run with no error when no error has been generated, and finally is going to run no matter what. So that's the output as expected. All right, let's continue moving on. Now there are times where you yourself want to raise an exception. You want to trigger an exception. So next question is, well, why do you want to do that? Well, sometimes the code logic would dictate that. I mean, right now we saw up here the different generic built-in exceptions like these. But sometimes you want to create your own custom exception that is based on the flow of your code or the requirement of your code. So down here we are going to learn about how do we raise purposefully an exception that is not part of the built-in Python exceptions. There we go. All right, and the way to do it is we use the raise keyword followed by the exception type followed by some sort of an error message that you want to pass when this error gets raised or gets triggered. So here we have a password validator example. Okay, you know how with passwords, when you try to create a new password, they stipulate that it has to be at least a minimum number of characters. It has to have an upper and lower letter. It has to have some sort of a number. It has to have some sort of a non-alphanumeric character like a question mark or a dash or an @ sign. So these are all requirements that we need to include. And if these requirements are not met, we want to raise a custom error. So typically there is no built-in exception that's part of Python that can handle that. So we have to create our own custom exception handler. So here it gives us an example. Now there's text here that says, don't worry about what a class is because we haven't learned about classes yet. All right, that's going to be part of the CSC 3 class next semester. So class is just a reserved word followed by the class name, which could be anything we call it, followed by something in parentheses. Now these parentheses, when you use parentheses after a class name, that means we are inheriting whatever is in this pre-existing class. So there is a pre-existing class in Python called exception. Again, class is not part of this semester, so I don't want you to be too hung up on it. But exception here is a name of a class, just like weak password error is the name of a custom class that I just created. Exception is an existing class in Python. So weak password error is going to inherit everything that's an exception. Again, you don't have to worry about this inheritance thing. I'm just casually mentioning it for you. Then we have the word pass. Pass basically is just a space filler, because if you create a class and have nothing in it, then it's going to give you a traceback error. Again, We don't need to learn about that now. This is for future classes. But just so you know what all this means. Again, class is a reserved word in Python. This is the class's name. This is the name of another class that this class will inherit from this class. Followed by a colon, followed by the word pass, which is another reserved word. Basically just to say that, hey, okay, weak password error is going to inherit everything in exception, but nothing's going to run. But it's going to inherit everything that's in here. Again, if this is too confusing, please don't worry and ignore everything that I said about these 2 lines of code here. Next, we have a definition of a function, which we know about functions, and it is taking one parameter called password. Within this function, I have all this code. All right, you're familiar with this code. So I have an if statement that says if the length of my password is less than 8, then do something. What is this something? Raise an error. So raise is a keyword or a reserved word in Python. This is going to raise an exception. What kind of exception? Well, the weak password error, which is the exception up here. And when you do that, I want also to pass this string value to print out. Now, I don't see anything here about printing out, right? But because the weak password error has inherited everything that's an exception, then the weak password error class now has functionality already pre-existing because it inherited whatever was an exception class. So I'm just going to raise this error, and I'm going to pass the text to be printed out as an output. All right, so that's if the length is of my password is less than 8. Now, if the password does not have any upper, okay, in my password value, then I'm going to again raise the weak password error exception, and I'm going to pass this string, which will be eventually outputted onto my screen. Password must contain at least one uppercase letter. And then if I don't have any lower letters, then again I'm going to raise the same custom error class, and I'm going to pass this string, which will eventually be outputted onto my screen. And if there are no numbers, I'm going to do the same thing. And then if none of these if statements have been triggered, then I'm just going to print password is strong, meaning that it met all my requirements. Okay, so if I attempt to run this, nothing happens because this function, which has all this functionality, has not been called, which makes sense. So now let's try this function out. Here are 2 ways to test the functionality. I'm going to have a try block. I'm going to call the validate password function, which is this. Now, you do need to run this function at least once. You get a check mark, because if you don't, then it's not going to be in the memory of this Jupyter notebook. And then when you come down here to run this code, this will generate an error because validate password, which is this function up here, has not been introduced to our code yet. So I run this code that doesn't do anything except it pulls this code into memory. And then when I come down here and I run this code, then it should work without giving me an error. So validate password is going to call this function, and this function is going to raise the error if it fails any of these checks. So here I have ABC123. This should raise an exception. Okay, this which is going to raise the exception here and print this is a weak password because again it's only 6 characters long. So I'm going to run this and I get this is a weak password. Notice how it did not generate the password must be at least 8 characters long. And we'll get to that in just a moment. But let's test when the password is strong, where we have this is the password I'm passing. It has capital letter, it's more than 8 characters, it has a digits, it has a small lowercase letters, and it has a non-alpha numeric digit. So run this, and now I get this is a strong password because it called this function up here. None of this worked, so I printed password is strong, which is what I see here. I'm sorry, what I see here. All right, so now we're going to bring in our weak password class. So now we're going to bring in the weak password error exception class, because remember up here when we did generate an error, it printed this. Okay, but I want it to that, you know, print these values. Okay, if it's less than 8, print this. If it's has not upper letters, print this, and so on. So I wanted to basically print whatever I pass it here, and not what I saw here, which was this is a weak password. All right. So the way to do that is like this. We're going to, again, try block. We're going to call the function. I'm going to pass it a value of a password that is too short. Okay. But instead of the except block that I saw up here, which is accept password error and get back a the print function, the print statement, I wanted to get the print statement that I've been customized up here. All right. And the way to do that is to, in the except block, call the name of your exception class and then use an aliasing of E. All right. And then print E. So E basically just, again, a short variable name for the weak password error class. And I'm going to print E, and we'll see what E prints out. And there we go. So E basically is the alias of my weak password error class, and it's going to print out whatever I passed as an argument, whatever I pass in my argument here. Okay, so again, call the function, give it a password. This password, if it fails, then it's going to raise the exception, weak password error, and it's going to print out the alias name, which includes the string as I have defined it up in my function here. All right, so just to recap, because this might be a little bit confusing, we're going to do a try block. I'm going to call a function. This function is going to include an argument. So this argument is going to go up to the function call validate password, which is here, validate password. And the parameter here was ABC123. And since the length of the password is less than 8, then I'm going to raise the exception, which is a custom exception class. And I'm also, when I raise this exception class, I'm also going to pass it the string value. And the string value is going to be used, because again, I didn't say how to use it, because it's being inherited with the exception class. Again, this is a little bit above our knowledge level, but that's, take it for granted from me for now. So I'm going to pass this value to this class, even though I don't see what happens with it here. And then down here, since I did capture this type of error, the weak password error, because I raised it, I purposefully raised it here. So then, so it got caught here. And what do I do with it? Well, I'm going to print E. What is E? Well, E is, for now, is the text that I passed when I raised the exception here, which is this guy here. All right, so this little concept might take a little bit of testing out and playing with it just so you can understand it. All right, so let's run this. And now, because this is a strong password, with this exception, we didn't have to go through this exception, but password is strong because none of this if statements answer to true, so we print password is strong. All right, here. All right, and now we have one more challenge. Let's say you want to create a function that only accepts positive numbers. If a user provides a negative number or a non-numeric value, you should raise an exception to handle the situation. Okay, so I came up with this code block, and this code cell basically does the same thing we've learned just a few minutes ago. I create a class, call it negative number error, you can call anything you want. That's going to inherit from the exception class, followed by a colon, and then the word pass, because there is no body for that class yet. Then I follow it with a function. Now the function basically says, well, it's called check positive, and it's going to accept one parameter. And then I'm going to say if the number is less than 0, which basically means it's a negative number, then I'm going to raise the negative number error. Okay, so see how here I'm raising the error on purpose. There is no error, a built-in error to capture in Python. There is no error to capture negative numbers, because negative numbers technically are allowed most of the time. But in my code requirement, I need to raise an exception when a negative number has been entered. So I'm going to use the raise reserved word followed by the name of my class, and then pass it whatever text I want to display as an output if that exception should be raised. And then if the number is less than 0, I'm going to raise this error, but if not, I'm going to return the number that was passed here. Okay, so that's my function. Then I'm going to come down to the try and except blocks. Okay, so in the try, I'm basically going to prompt the user to enter a positive number. If they enter a positive number, then everything's going to run happily correctly. If they enter a negative number, then when we come to the function call using a negative number, it's going to go up to this function, and then if the number is less than 0 because it's negative, yes it is negative, then it's going to raise this negative number error exception, okay, which is then going to come down here, and here's the exception type of negative number error, which got raised up here, and then I'm going to alias it, although you don't have to alias it, but I choose to alias it just with the letter E, and then I'm going to print out whatever comes back from the letter E, which should be this value that I just passed when I raised this negative number error. So if I run this code and I do a -9, hit enter, I get the number must be positive, which is what the exception returned as an output. If I give it a positive number, 9, hit enter, nothing happens because there is no print statement when the try works fine. Okay, now we have our final challenge, okay, which basically says let's apply what we've learned to make our chatbot more robust when working with files. Especially in a program that both reads from and writes to files, it's crucial to handle situations where the file might not exist yet. This final challenge will help you focus on working with missing CSV files. All right, so this code was from last week where we worked with the policies.csv file. So this code should look very familiar to you. Now if I run this as is now, okay, I get an error. It's a traceback error, and the type is no such file or directory. So now we need to update this code to include error handling to gracefully handle our errors and not generate the traceback error of no such file or directory. So down here I have the same code, but I just basically wrapped it up into try and except blocks to help us capture this problem should it happen again. Okay, so here again is the code from last week, which is the code from up here. And the difference is now I took any code that has to do with error prone, which in our case is code that would use file reading or file writing mechanisms. For example, this is going to read from a file, so I put that in a try block. Okay, and then if I want to handle a file not found error in my except block, I'm saying that if you do get a file not found error, then do this. What does this do? Well, if the file doesn't exist, then I need to create the file, not just create the file, but also write the keyword and response as my first line in my policy.csv file. Okay, and then we're going to return an empty dictionary because our data has been converted to a dictionary, so I want to work with data type dictionary. Okay, so again, it's the same exact code, these 3 lines, but I lumped them up into a try block, and if for whatever reason the file doesn't exist, which it can happen, then it's going to raise a file not found error. So since there is no file, but I still want to process the job, then I will open the file as a W access mode, which is a write access mode. So the file doesn't exist. I know it doesn't exist because I just found out here from the file not found error. So the W is going to write this data into the new file. Okay. So now that I have a new file called policies.csv, and I wrote the first line, which is keyword, comma, response, followed by a new line entry. Then I want to start writing more new policies to it, which is the paternity and paternity details, okay, which is going to happen by this function call, the write new policy to CSV, which is going to call this function up here. Okay, and what this function here is going to do is it's going to attempt to write data to the policies.csv file, but it's going to not create it, it's going to try to append data to it, which is again this data here. Okay, now should for whatever reason this file name doesn't exist, then it's going to raise the file not found error, and then I'm going to still write the data, okay, to that file name, which is these two keywords and response. So let's try that. I'm going to run this, and it ran fine without errors, as you can see from the check mark here. So that means that this policy.csv file is somehow within my system. So let's go to the files area, and here it is. Okay, so if I double click on it, it's going to load it here, and here's keyword response, and it added this. All right, now if I close this file and I delete this file, and run my, so now there is no policy.csv, but if I run it now, okay, scroll down here, instead of generating an error, I mean, it did find that the file doesn't exist because it doesn't exist. Now it showed up because I just created it. I made it to this exception block. It created the file using the W access mode, and it created this keyword response. And then down here, this happens because of this line. This line is a function call to load responses from CSV, which is this function. And then this code runs with a try except. So it's going to create a file and just add this one line to it, keyword comma response. And then in my code, it's going to come down to this function call, which is then going to create a new policy and give it this keyword response value. So if I open this, I see that. Okay, and if I close this and I run this again, and now I'm going to refresh my policy CSV file and open it. Now I see that it entered the paternity and its value twice. Well, once was from the first run, this is from the second run, because again, when we come down to write the new policy to CSV, it does find the file, so it's in the try block, so it's not going to error out. So it appends whatever I passed it to the file. What did I pass? I passed this keyword response. If I change this to paternity 2, and then run it again, okay, I get a check mark, which is good. Now let's refresh this file and let's open it up. Now I see the paternity 2 has been added as well. So this means that my code has been working, and again, if a file not found error has been found, it's not going to yell at me, but it's going to get caught, and the exception will be handled this way. The same thing as well for here, it will be handled this way. Okay, and so that wraps up this assignment. And then for the submission part, it says ensure your progress is saved. Download the file by going to File, Download, and then save your IPy-NB file. Also hit the share up here to get the link, and then submit everything in the Canvas submission area. And if you have any questions, of course, do reach out to me at any time. All I ask is that you, if there's an error or something is wrong, just please send me a copy of your Jupyter Notebook file as well as a screenshot of the error, and I'll definitely work with you and help you out. So thank you for watching. I hope this was helpful. Take care, and bye for now.